Hello there, and welcome to the Sleepy Astronaut channel. I'm so glad you found your way here tonight. Maybe it's been a long day, or maybe you're someone who likes to drift to sleep with quiet wonder, letting thoughts of distant worlds replace the noise of daily life. There's nothing you need to do now, but rest. Let your mind grow still, your breathing slow, and your body light. Because tonight, we're not just closing our eyes. We're traveling into the deepest mysteries of the cosmos, the realm of black holes. From dying stars to the silent centers of galaxies, we'll explore 100 sleepy facts to help you relax, unwind, and dream of the universe's calmest darkness. Now, close your eyes, and let's begin. Fact 1. The gravity that grew too strong. Every star lives a life of balance, a steady tug of war between gravity pulling inward and heat pushing outward. But when a star many times larger than our sun runs out of fuel, that balance breaks. With no more energy to resist its own weight, the star begins to collapse. The fall is unstoppable, its core crushed tighter and tighter until it becomes something utterly different. Its gravity grows so fierce that not even light, the fastest traveler in existence, can escape. What remains is a point of perfect stillness and infinite pull. This is how a black hole is born, not from chaos, but from the quiet surrender of a dying star. And in that silence, a new mystery begins. Fact 2. Stars that died into darkness. Some stars end their lives gently, shedding layers into glowing clouds that drift away like cosmic ghosts. But the most massive stars meet a more dramatic fate. When their nuclear fire fades, their hearts implode, and the outer layers collapse inward at nearly the speed of light. The core is crushed into a single, invisible point, a singularity. Around it, space itself bends so sharply that all paths curve inward. No force can turn back. The star's light vanishes, its shape dissolving into shadow, and what's left is not an object but a region, a place where gravity reigns completely. Astronomers call it a black hole, but in truth, it's more like a memory of a star, the echo of brilliance folded into eternal night. Fact 3. When light couldn't escape. Light has always been our way of seeing the universe, the messenger of stars and galaxies, the gentle traveler across billions of years. Yet near a black hole, even light meets its limit. The gravitational pull is so absolute that every beam of light bends, curves, and finally spirals inward. Once it crosses the invisible boundary known as the event horizon, it can never return. From outside, the black hole looks perfectly dark, a smooth sphere of nothingness. But this nothing is not empty. It's the densest place in the universe. To watch a black hole is to watch the triumph of gravity over light, the softest of cosmic paradoxes. And though we cannot see what lies within, we can feel its quiet influence rippling through space itself. Fact 4. The collapse of a giant's heart. At the end of a massive star's life, its core becomes heavy with iron, an element that cannot release energy through fusion. Without that vital pressure, gravity wins. The heart of the star begins to collapse inward with unimaginable speed, crushing atoms and shattering structure. In a final, violent heartbeat, the star's outer layers rebound and explode outward as a supernova, one of the brightest events in the universe. Yet deep within that fading fire, the core continues to fall. It contracts beyond atoms, beyond light, beyond comprehension, until all of its mass is compressed into a single, infinite point. This moment marks the silent birth of a black hole, the instant when time, space, and matter surrender to gravity's gentle, eternal command. Fact 5. The last breath of a sun. When a star collapses, not all of it vanishes into shadow. In those final moments, it releases a wave of energy so immense that it briefly outshines entire galaxies. This is the star's last breath, a farewell carried across the cosmos in light and dust. The outer layers scatter into space, becoming the seeds for future stars, planets, and maybe even life. But the heart of the star falls inward, leaving behind a black hole, a quiet core that keeps the memory of its brilliance hidden behind an invisible veil. Though its light is gone, its gravity continues to whisper through the universe, shaping the orbits of stars and the paths of galaxies. Every black hole, in a way, is the echo of a star that once burned bright and warm. Fact 6. The quiet singularity within. At the center of every black hole lies a place where our understanding falters. The singularity. It is a point where gravity is infinite, space is curved beyond measure, and time as we know it no longer flows. The laws of physics break down here, replaced by something we cannot yet describe. No observer can ever see the singularity directly. It hides behind the event horizon, wrapped in perfect darkness. Yet its presence defines the black hole's every motion, every orbit, every whisper of gravity. It is the silent heart of the void, infinitely small, infinitely dense, and infinitely mysterious. To imagine it is to glimpse the edge of knowledge itself, where science turns into wonder and the universe keeps its deepest secrets safe in sleep. Fact 7. A hole that isn't empty. Despite its name, a black hole is not truly a hole in space. It's a region filled with gravity so strong that nothing inside can escape. The matter that once made up a star hasn't vanished. It has simply been compressed beyond visibility, beyond form. Around the black hole, a storm of energy often swirls. Glowing disks of gas heated as they spiral inward, releasing the last of their light before being consumed. What seems like emptiness is actually full of motion, radiation, and magnetism, an invisible orchestra playing beneath the silence. Even though no light escapes from its heart, the space around a black hole shines with fierce brilliance, proof that what we call nothing can, in truth, be teeming with hidden life and cosmic fire. Fact 8. Boundaries of no return. Every black hole is surrounded by an invisible frontier called the event horizon, the boundary beyond which escape is impossible. Imagine space itself flowing like a river toward a waterfall. Far away, you could still paddle upstream, but near the edge, the current grows too strong, pulling everything down into the fall. The event horizon is that edge, the place where even light can no longer swim against gravity's pull. From outside, this boundary looks peaceful, perfectly still, as if nothing unusual lies beyond it. Yet crossing it would mean leaving the visible universe forever. It's a line drawn not by walls or matter, but by the nature of space-time itself. A silent reminder that even the vast cosmos has places where return is no longer possible. Fact 9. The shadow, called the event horizon. Though we cannot see a black hole directly, we can glimpse its outline, a dark shadow against the glowing light around it. This shadow isn't the hole itself, but the region where light bends and vanishes into its gravity. The Event Horizon Telescope captured this haunting image in 2019, a ring of fire encircling a perfect darkness. That soft, glowing halo was light from gas and dust, swirling near the event horizon, heated to millions of degrees as it fell inward. What we saw was not destruction, but balance. Gravity holding the universe's brightest light at its very edge. The black hole's shadow is both an absence and a revelation, proof that even in darkness, beauty finds a way to be seen. Beyond that, time itself begins to slow and stretch toward forever. Fact 10. Time slows at the edge. Near a black hole, time itself begins to behave differently. To an outside observer, anything falling toward the event horizon seems to slow down, moving more sluggishly the closer it gets, until it appears frozen in place. This is not an illusion, but a truth of relativity. Gravity stretches time. The stronger the gravity, the slower the clock ticks. From the perspective of the falling object, however, nothing strange happens. It continues smoothly across the horizon, unaware of its eternal pause in another's eyes. In this strange divide, black holes reveal that time is not constant. It breathes and bends like fabric. At the edge of a black hole, even seconds become infinite. It's as if the universe itself is holding its breath, letting time rest quietly in its shadow. Fact 11. Beyond the horizon's veil. What lies beyond the event horizon remains one of science's most profound mysteries. No signal, no photon, no whisper can cross back from that boundary to tell us what happens inside. The equations of physics work beautifully up to the horizon's edge, but beyond it, our understanding dissolves. Some theories imagine a journey inward, through warped spacetime, where direction and distance lose meaning. Others suggest that what falls in is forever lost to our reality, leaving behind only its gravity and spin. The truth is hidden behind an unbreakable curtain, one drawn not by secrecy, but by nature itself. When we gaze at a black hole, we are looking at the limit of human knowledge, the place where discovery stops and wonder begins, quietly glowing at the edge of forever. Fact 12. The singularity's hidden core. Deep within every black hole, past all horizons and illusions, lies the singularity, a point where all known physics collapses. It is not a surface or a place we could stand upon. It is a concept, a realm where density becomes infinite and space folds into itself. Here, time may cease to exist, and distance loses meaning entirely. We cannot observe it, but we can sense its influence, the way it shapes the orbits of stars and pulls galaxies into elegant spirals. Scientists believe the singularity is the universe's way of keeping its deepest secrets veiled, a silent reminder that some truths are meant only to be imagined. In the still center of that darkness, everything that was, light, matter, energy, rests in absolute peace, beyond time, beyond end. Fact 13. Spacetime curved like a sea. Einstein once described gravity not as a force, but as the bending of spacetime, a four-dimensional fabric that curves around mass. Imagine space as a calm sea, and a star as a smooth stone resting upon its surface. The heavier the stone, the deeper the curve. A black hole, then, is like a whirlpool, a place where the sea folds so steeply that nothing, not even light, can escape its pull. The closer you drift, the more space and time twist around you until forward motion becomes a spiral toward eternity. To look at a black hole is to see the universe reshaping itself, not chaos, but a perfect curve of stillness. Beneath that invisible surface, space-time doesn't just bend, it falls inward, endlessly, into its own reflection. Fact 14. Mass folded into infinity. When a black hole forms, an enormous amount of mass is squeezed into an impossibly small volume. Imagine something as heavy as the sun, or millions of suns, compressed into a single point. The density becomes infinite, at least as far as our equations can describe. In this state, gravity no longer has a surface to cling to. It becomes pure curvature, pure geometry. Everything that falls in adds to this fold, deepening the pit in space-time and strengthening its invisible pull. From a distance, the black hole may appear simple, defined only by its mass, spin, and charge. Yet within lies infinity itself, wrapped inside the quiet laws of nature. It is the universe's ultimate paradox, the smallest thing containing the largest truth. Fact 15. Where space and time trade places. Inside a black hole, the familiar rules of direction no longer apply. In ordinary space, time moves forward and space stretches around us. But beyond the event horizon, their roles begin to blur. Moving deeper into the black hole isn't a choice. It's as inevitable as moving forward in time. In that strange realm, space points inward, and time itself becomes the fall. Every path leads closer to the singularity, not by force, but by the simple geometry of existence. It's as if the universe redefines motion within that shadow, turning space into destiny and time into surrender. Beyond the horizon, falling inward is no longer movement through space, but the natural passage of time itself, slow, unstoppable, and perfectly quiet. Fact 16. The photon sphere's gentle glow. Around every black hole exists a delicate, ghostly ring where light itself becomes trapped in orbit. This is called the photon sphere, a place where gravity bends light into circles, neither letting it escape nor allowing it to fall. A photon traveling here could circle the black hole many times before slipping away or being swallowed whole. If you could somehow watch this from afar, you'd see a shimmering halo of twisted light, bent and layered upon itself, like reflections on rippling water. The photon sphere marks the balance between freedom and forever, a silent boundary where light performs its endless, graceful dance. It is the black hole's faintest whisper of visibility, a delicate trace of what once was, glowing softly against the darkness that waits beyond. Fact 17. The accretion disk that burns like gold. Before matter disappears into a black hole, it gathers into a swirling, radiant disk called an accretion disk. Gas, dust, and even fragments of stars spiral inward, moving faster and faster until friction heats them to millions of degrees. This makes the disk shine with fierce beauty, sometimes brighter than entire galaxies. To distant telescopes, these glowing rings look like halos of fire, spinning in perfect harmony around the darkness. But the heat is not anger, it's transformation. Every particle in that disk gives up its last light, turning motion into energy before crossing the horizon. From far away, it looks like gold encircling silence, a cosmic candle flickering before it fades. In those final orbits, matter performs one last luminous dance, a farewell to visibility. Fact 18. Jets that pierce the void. Strangely, not all matter falling toward a black hole is lost. Some of it escapes, not as light, but as powerful jets of energy shooting out from the poles at near the speed of light. These jets can stretch across thousands of light years, glowing with radio waves and X-rays. They are formed by the tangled magnetic fields of the accretion disk, which twist and channel charged particles outward. To the eye, they appear as brilliant beams cutting through space, linking the unseen heart of the black hole to the stars beyond. In the quiet of the cosmos, these jets are like lighthouses in the dark, guiding astronomers to the places where creation and destruction meet. Through them, the black hole breathes energy back into the universe it consumes. Fact 19. The silent spin of Kerr. Black holes. Not all black holes are still. Many rotate, spinning at extraordinary speeds, some near the speed of light. These are called Kerr black holes, named after the scientist who first described their nature. Their rotation drags the very fabric of space around them, a gentle yet unstoppable whirlpool of time and gravity. This twisting motion creates a region called the ergosphere, where nothing can stay still, not even light. Within this silent storm, energy can be borrowed, motion can reverse, and particles can dance in strange orbits. The spin gives the black hole both beauty and complexity, transforming it from a static shadow into a living, turning presence. In its rotation lies a quiet grace, as if the universe itself is slowly stirring its deepest thoughts. Fact 20. Charged, rotating, timeless. In theory, a black hole can possess three simple traits: mass, spin, and charge. These alone define everything about it. A charged, rotating black hole, called a Kerr-Newman black hole, is a solution to Einstein's equations that seems both simple and impossible. The rotation weaves space-time into spirals, while the electric charge bends fields in ways we can only imagine. Yet even with all this complexity, the black hole remains timelessly calm, shaped by pure geometry. Scientists sometimes call this the no-hair principle. Black holes reveal nothing beyond those three numbers, no matter how they were born. It's a humbling thought that all the chaos of matter, light, and motion can be distilled into quiet simplicity. Each black hole is a perfect equation carved into space-time's silence. Fact 21. Seeds from ancient stars. Long before galaxies had shape, the first black holes may have been born from the universe's earliest, most massive stars. These ancient suns, hundreds of times heavier than ours, burned fast and fierce, living only a few million years before collapsing into darkness. The black holes they left behind became the seeds of galaxies, gathering dust, gas, and light around them until stars began to form again. Over billions of years, these small shadows grew into cosmic giants, the supermassive black holes that now anchor galaxies like our own. Every glimmering spiral, every quiet cluster, may trace its lineage back to these first collapses. In their silence, the universe found its structure, and from death, it built creation. The seeds of night became the gardens of stars. Fact 22. When galaxies give birth to giants. As galaxies form and merge, black holes grow with them, feeding on gas, dust, and even other stars drawn too close. Over cosmic ages, these small beginnings swell into supermassive black holes, millions or even billions of times heavier than the Sun. Their growth is gentle yet unstoppable, guided by the same gravity that shapes galaxies themselves. Sometimes, when matter falls inward too quickly, the black hole blazes with radiation, becoming what we call a quasar. a lighthouse visible across the universe. But even these giants were once humble, born from the collapse of ancient stars. Every galaxy carries their signature, a quiet echo of those first dark seeds. In this way, black holes are not destroyers, but creators, the silent centers around which galaxies find their balance and form. Fact 23. Supermassive hearts of galaxies. At the heart of nearly every large galaxy lies a supermassive black hole, an object millions of times the Sun's mass, yet compressed into a region smaller than our solar system. These colossal beings anchor the stars that swirl around them, shaping their motion like a conductor guiding a quiet orchestra. The Milky Way's own heart, Sagittarius. A star is one such black hole, calm now, but once bright with feeding energy in its youth. Without these immense centers, galaxies might never hold together. Their spin and spiral depend on the gravity deep within. Though we call them black holes, they are the cosmic hearts that keep galaxies whole, beating invisibly in the dark. Around them, stars rise and fall, while the center remains, silent, steady, eternal. Fact 24. The sleeping giants in the center.
Most supermassive black holes today are quiet, no longer feeding on the matter that once made them shine. They sleep at the centers of galaxies, wrapped in calm. Yet their presence is still felt, in the way stars orbit faster near the core, in the soft hum of radio waves that sometimes escape their edges. Occasionally, a passing cloud or drifting star awakens them, and for a while, the giant stirs, glowing again as it consumes. Then as quickly as it awoke, it settles back into stillness. These black holes may slumber for millions of years, their energy resting deep inside the fabric of space-time. Like a breath held between ages, they wait, patient, ancient, and unchanging, while galaxies continue their slow, spiraling dance around their invisible hearts.
Fact 25. The smallest black holes of all. Not all black holes are giants. Some are only a few times heavier than our Sun, born from the collapse of massive stars at the end of their lives. These stellar black holes are scattered throughout galaxies, hidden companions to bright stars or drifting quietly in solitude. Their gravity is fierce but local, curving the space nearby without disturbing the vastness beyond. Astronomers find them by watching how nearby stars move, dancing slightly offbeat, tugged by an invisible partner. Though small, these black holes are powerful, converting collapsing matter into bursts of X-rays and energy. They remind us that even the smallest darkness can hold enormous force, and that power in the universe often comes not from size or light, but from quiet density, the calm concentration of being. Fact 26. Primordial shadows from the early universe. Some scientists believe that the very first black holes were not formed from stars at all, but from the dense, turbulent matter of the early universe itself. These are called primordial black holes, ancient shadows that may have appeared just moments after the Big Bang. They could range in size from tiny specks smaller than atoms to objects heavier than mountains. If they exist, they might still drift through the cosmos today, silent and unseen. Some may even make up a portion of the mysterious dark matter that shapes galaxies. Though none have yet been confirmed, the idea is enchanting, that before stars, before light, before galaxies, there were black holes waiting in the dark. The universe, it seems, may have carried its seeds of stillness from the very beginning. Fact 27. Merging masses in the dark. Black holes rarely remain alone forever. Over time, galaxies collide, stars wander, and sometimes two black holes find each other in the quiet depths of space. Drawn together by gravity, they begin a slow spiral, orbiting closer and closer as they lose energy through invisible ripples called gravitational waves. When they finally merge, they create a single, larger black hole, releasing a burst of energy that briefly shakes the fabric of space-time itself. These mergers are not violent explosions, but elegant fusions, two darknesses becoming one, their masses combining in perfect silence. Instruments like LIGO and Virgo can detect these faint ripples, listening to the universe's softest music. Each detected wave is a cosmic heartbeat, a reminder that even in the quietest corners of creation, something is always moving, joining, and becoming whole. Fact 28. Growing by consuming light. A black hole grows not through sudden bursts, but through slow, patient feeding. As gas, dust, and even starlight drift too near, they spiral inward, forming glowing disks that radiate their final energy before crossing the horizon. Every bit of matter that falls in adds to the black hole's mass, deepening its gravity, expanding its influence. The process can take millions of years, yet in the scale of the cosmos, it's as natural as breathing. In consuming light, the black hole does not destroy, it transforms. Energy becomes gravity, motion becomes stillness. The brilliance that once shone outward now rests, folded into silence. Growth in the life of a black hole is a quiet act of balance, an eternal exchange between light and the unseen hand that gathers it home. Fact 29. The quiet feast of matter. When a star wanders too close to a black hole, its own gravity cannot hold it together. The immense pull stretches it into a long, glowing stream, a process called spaghettification. The star unravels, its gas winding into the accretion disk like silk caught in a whirlpool. The black hole feeds slowly, each strand of matter heating, glowing, and vanishing beyond the horizon. From afar, it appears almost peaceful, a soft flicker of X-rays, a gradual dimming as the star becomes part of the void. This quiet feast is not destruction, but transformation. The star's light converted into energy, its essence folded into the structure of space-time. Even in their hunger, black holes consume with elegance, leaving behind not chaos, but calm, the eternal rhythm of matter returning to its source. Fact 30. How a black hole grows old. Though they seem immortal, black holes too have a kind of aging. Over eons they merge, feed, and sometimes even fade. Each one carries the memory of every particle it has consumed, its mass a quiet record of time itself. In isolated corners of the cosmos, where no new matter drifts near, a black hole may slowly lose energy through Hawking radiation, tiny flickers of heat escaping from its horizon. The process is unimaginably slow, taking trillions of years to dim completely. Yet it means that even the darkest things in the universe are not forever. They too will one day fade into nothing. The life of a black hole is a patient cycle, born from fire, grown through light, and ended in silence. In the end, even gravity dreams of rest. Fact 31. Stars caught in orbit. Even in the deep silence around a black hole, some stars endure, circling it in steady, graceful orbits. These stars never fall in. They are bound by gravity, but safe from its final pull. Around Sagittarius, a star, the supermassive black hole at the center of our Milky Way, astronomers have watched such stars dance for decades. One of them, named S2, completes its long, elegant orbit every 16 years. As it passes close, its light bends and shifts, revealing how space itself is curved by the unseen mass at the center. Watching these orbits is like reading the black hole's heartbeat, invisible, yet felt through the motion of others. It's proof that even around darkness, life persists, circling in quiet harmony, glowing softly against the pull of eternity. Fact 32. The glow around the darkness. A black hole may be invisible, but the space around it often shines with fierce light. The swirling matter in its accretion disk glows brighter than 1 billion suns as it spirals inward, its atoms colliding and heating to incredible temperatures. From a distance, this light outlines the black hole's shape, creating the illusion of a radiant ring encircling nothingness. It's the glow of transformation, energy being freed in its final moment before silence. Even as matter disappears, its light lingers, like the last breath of a candle before it fades. Through this luminous halo, astronomers can glimpse the black hole's influence, the way it sculpts light and bends reality. Around every shadow, the universe paints a soft edge of gold, reminding us that even darkness has its glow. Fact 33. How we see the unseeable. For centuries, black holes existed only in theory, mathematical whispers hidden within Einstein's equations. Then, in 2019, the Event Horizon Telescope captured the first real image of one, a glowing ring surrounding a shadow, nestled in the galaxy M87, 55 million light-years away. This picture wasn't taken by a single telescope, but by a network of observatories across Earth, synchronized to act as one enormous eye. What we saw was not the black hole itself, but its absence, the light it captured, framed by the light it released. It was the universe looking back at us through its own reflection. Seeing that shadow was like glimpsing the soul of gravity, the point where light surrenders and time stands still. It reminded us that even what cannot be seen can still be known and deeply felt. Fact 34. The first image of a black hole. In April 2019, humanity saw the impossible, the first real image of a black hole. It wasn't just a photograph, it was a window into the unknown. Captured by the Event Horizon Telescope, the image revealed a glowing orange ring surrounding a dark center, the black hole in the galaxy M87. That darkness was not emptiness, but the event horizon itself, the point where light vanishes forever. The image took years of collaboration, data, and patience from scientists around the world who turned the entire Earth into one vast, synchronized eye. When the image was revealed, many described it as seeing the face of gravity. It was proof that what once lived only in theory could be seen, felt, and understood. A moment when science met awe, and the universe finally showed its shadow. Fact 35. The Ring of Fire at M87. The black hole at the center of Messier 87, a galaxy 55 million light-years away, is a true cosmic titan. It holds a mass more than 6 billion times that of the Sun, and around it swirls a glowing halo of gas and plasma, the accretion disk. This disk shines with such intensity that even from across galaxies, its light reaches us. The image captured in 2019 revealed a golden ring, light distorted by immense gravity, bent into a near-perfect circle. This ring of fire isn't flame, but the last visible moment before matter crosses the event horizon. To look at it is to see energy, motion, and silence woven together. That soft glow marks the boundary between existence and disappearance, a delicate balance where the universe holds its breath and light says its final goodbye. Fact 36. Event Horizon. Telescope's quiet victory. The Event Horizon Telescope, EHT, wasn't a single instrument, but a network of radio observatories scattered across our planet, from Chile's Atacama Desert to the icy peaks of Hawaii. Together, they worked as one, creating a telescope the size of Earth itself. For days, these observatories gathered radio waves emitted near the black hole in M87, then combined their data to form an image with astonishing clarity. The result was more than a picture. It was a triumph of patience and human unity. Thousands of terabytes of data, synchronized with atomic clocks, revealed a sight that had existed for billions of years, waiting quietly for us to notice. The EHT's success wasn't loud or dramatic. It was serene, almost spiritual, a reminder that discovery often happens in stillness, when we simply learn to listen to the silence of the stars. Fact 37. Light bending in perfect circles. Near a black hole, light doesn't travel in straight lines. It curves, folds, and loops around the massive pull of gravity. This phenomenon is called gravitational lensing, and it turns the region around a black hole into a cosmic mirror, where light from distant stars is bent into arcs and halos. In the most extreme cases, light can orbit the black hole several times before escaping, forming a ring of perfect symmetry called an Einstein ring. What looks like magic is simply the geometry of spacetime, light following the contours of gravity's invisible hand. From far away, it creates an illusion of beauty, born from distortion. Every bent photon is a silent witness to gravity's artistry, sketching delicate circles of light around the calmest darkness in the cosmos. Fact 38. Time's reflection in gravity. Gravity doesn't just shape space, it stretches time itself. Near a black hole, time slows so dramatically that a single moment at the edge could pass as centuries elsewhere. This strange relationship, predicted by Einstein, means that observers far away would see clocks near a black hole tick slower and slower, while those falling in would notice nothing unusual at all. Time, like light, becomes curved by gravity's will. In this gentle warping, the universe reveals its most poetic truth, that motion, space, and time are threads of the same tapestry. To watch a black hole is to glimpse time reflected back upon itself, a cosmic echo of beginnings and endings intertwined. In that quiet distortion, the universe whispers that even eternity can be stretched, folded, and softened by gravity's touch. Fact 39. Echoes of X-rays and radio waves. Though black holes themselves emit no light, the regions around them are alive with soundless echoes of energy, bursts of X-rays, flickers of radio waves, and pulses that ripple across space. These emissions come from the heated gas and plasma, swirling near the event horizon, releasing energy as they spiral inward. Astronomers use these invisible signals to map what they cannot see, translating cosmic silence into data, color, and understanding. Each wavelength tells a story of motion, heat, magnetism, and time. It's as if the black hole hums softly to the universe, a deep, slow melody beyond hearing. These faint echoes remind us that even the quietest corners of creation have a voice, one that speaks not in words, but in waves, resonating through the endless calm of space. Fact 40. Seeing shadows through silence. Astronomers have learned to study black holes not by what they emit, but by what they erase. The shadow of a black hole is a dark circle surrounded by glowing matter, a quiet absence that reveals its presence. Through radio telescopes and X-ray observatories, scientists watch the subtle motions of gas, tracing invisible forces that shape entire galaxies. It is a form of listening rather than seeing, interpreting silence as signal. The shadow, calm and constant, tells us where gravity has folded space too tightly for light to return. It's an image drawn not in color, but in contrast, not in brightness, but in stillness. In that darkness lies understanding. The universe doesn't always speak in light. Sometimes it whispers through absence, teaching us to see what can't be seen. Fact 41. Einstein's equations come alive. When Albert Einstein published his theory of general relativity in 1915, few imagined it would one day describe something as astonishing as black holes. His equations showed that massive objects warp space and time, like weight pressing into a stretched fabric. Decades later, scientists realized these same equations predicted something even stranger, regions where the fabric would fold completely, trapping light. For Einstein, this idea was unsettling. He doubted nature would allow such extremes, yet the universe proved otherwise. Today, every observation of a black hole is a living echo of Einstein's mathematics. Curved space-time made real. His theory, once lines on paper, now hums through the cosmos, shaping the movement of galaxies and the passage of time. It's a quiet triumph of thought, that human imagination could foresee the most mysterious truth of all: gravity's perfect silence. Fact 42. General relativity's darkest prediction. Black holes are not an invention of science fiction, but the natural consequence of general relativity, the theory that space and time bend around mass. Einstein's equations allowed for places where this curvature becomes infinite, singularities hidden within event horizons. For years, physicists debated whether such objects could truly exist. Then came the evidence, the orbits of stars, the X-ray bursts, the shadow in M87, all aligning with his predictions. What began as mathematics became cosmic reality. General relativity's darkest prediction turned out to be one of nature's most elegant creations. It showed that gravity isn't just a force pulling on matter, but a sculptor shaping time itself. In every black hole, Einstein's vision lives, not as a theory, but as a deep, steady truth, written in the quiet curves of space-time. Fact 43. Space-time as fabric, black holes as folds. Imagine the universe as a vast, invisible fabric, smooth, continuous, and alive with gentle ripples. This fabric is space-time, and everything that has mass or energy presses upon it. A planet makes a shallow dip, a star creates a deeper one, and a black hole forms a fold so steep that it curves back upon itself. Gravity, then, is not a mysterious force pulling objects together. It is the motion of things following these curves. When we orbit the sun, we are simply gliding along space-time's bend. A black hole, however, represents the ultimate fold, the place where the fabric turns inward, wrapping light and time into its own shadow. It's not an absence, but a deeper layer of the same cosmic cloth, woven by gravity's patient hand. Fact 44. The strength of curved geometry. In the calm logic of Einstein's theory, geometry itself replaces the need for invisible forces. The curvature of space-time tells matter how to move, and matter tells space-time how to curve. Near a black hole, this relationship becomes beautifully intense, the geometry so warped that straight lines no longer exist. What we call falling is simply matter following the shortest possible path through curved spacetime. The stronger the mass, the deeper the curve, until the path leads inward forever. It's a quiet exchange between shape and motion, like a dance between time and gravity. Every black hole is a perfect example of this balance, a structure built entirely from geometry, smooth and absolute. In their silent simplicity, black holes remind us that even the universe's greatest strength is born not from chaos, but from graceful curvature. Fact 45. Mass, energy, and the shape of reality. Einstein's most famous equation, E equals mc squared, reveals that mass and energy are two forms of the same thing: interchangeable, inseparable, and fundamental. This truth lies at the heart of every black hole. When a star collapses, its energy becomes density, its light becomes gravity. What remains is a shape in space-time so pure that it no longer needs matter to define it. The black hole itself is geometry given form, energy folded into structure. Around it, the universe adjusts. Light bends, time slows, motion curves. Mass is no longer a thing, but a condition, a quiet deformation of the cosmos. In that understanding lies a kind of beauty, that all existence, from the smallest atom to the darkest abyss, is woven from the same thread, energy taking shape in the still fabric of reality. Fact 46. The twin paradox in orbit. Imagine two twins. One remains on Earth, while the other travels close to a black hole. To the traveler, time flows normally. Every second, every heartbeat feels the same. But to the twin left behind, those moments stretch into years. When the traveler returns, they would find their sibling older, while they remain young. This is the twin paradox, a beautiful consequence of relativity. The deeper you move into a gravitational field, or the faster you travel through space, the slower time passes for you. Black holes make this difference immense, turning moments into centuries. Though it sounds like fiction, it's pure physics. Time and motion are not separate things, but threads of the same tapestry. Around a black hole, those threads twist so tightly that even the passage of life itself bends and softens into stillness. Fact 47. Clocks that freeze at the horizon. From far away, anything falling toward a black hole seems to move slower and slower, as if caught in a timeless pause. To a distant observer, it would appear that the falling object never quite crosses the event horizon. Its clock slowing to a stop, its image fading into red light before vanishing. But from the object's own point of view, the journey continues smoothly, with no sign of freezing or delay. This strange difference is not illusion, but perspective. Time itself flows differently depending on where you stand in gravity's curve. The horizon, then, is not a wall, but a mirror, reflecting how space-time divides experience. What one sees as eternity, another feels as a single breath. In this quiet paradox, black holes teach us that even time can hold two truths at once. Fact 48. Gravity as slow time. Gravity is not just a force that pulls, it's a phenomenon that slows the rhythm of time itself. Near a massive object, seconds pass more gently, stretched by the weight of spacetime's curve. On Earth, this effect is tiny. Atomic clocks on mountaintops tick slightly faster than those at sea level. But near a black hole, it becomes profound. There, Minutes for one observer could mean millennia for another far away. This concept, known as gravitational time dilation, reveals a simple yet humbling truth. The flow of time depends on where you stand in the universe's embrace. Closer to mass, time rests. Farther away, it dances freely. In that slowing lies something beautiful, a cosmic reminder that even the ticking of existence can soften, yielding to the quiet patience of gravity. Fact 49. Falling forever in finite moments. To an outside observer, anything falling into a black hole seems to take forever. The object slows, dims, and fades as its light stretches into red, frozen at the edge for eternity. But for the traveler falling inward, time feels normal. In mere seconds, they would cross the horizon and fall toward the singularity, unaware that the rest of the universe is watching them pause forever. This paradox reveals how gravity warps not only space, but perception itself. Forever and moment lose their meaning here. Both exist at once, divided by perspective. It is one of the most haunting truths of the cosmos, that time can end for one observer while continuing for another. In a black hole's embrace, the idea of now dissolves, replaced by quiet, endless descent. Fact 50. The horizon's gentle illusion. The event horizon is often imagined as a hard boundary, a wall between existence and oblivion. But in truth, it's a smooth, invisible surface in space-time, with no physical barrier to touch or see. If you could cross it, you wouldn't feel a thing. It's only from far away that it appears as a glowing edge, a circle of darkness outlined by light. This illusion comes from the way gravity bends space and time, hiding what happens beyond. The horizon is not destruction, but transition, the point where paths through the universe turn inward instead of outward. To call it an end is human. To the cosmos, it's simply a change of direction. The event horizon is a mirror of perspective, reflecting both the limits of vision and the boundless patience of the universe. Fact 51. Two shadows become one. In the vast quiet of the universe, even black holes find each other. Drawn together by gravity, they spiral in a slow, elegant dance that can last for millions of years. As they draw closer, space ripples around them, carrying away energy in the form of gravitational waves, faint tremors that stretch the very fabric of reality. When they finally merge, their shadows fuse into one, forming a single, larger black hole. The moment of union is silent yet powerful, releasing more energy in an instant than all the stars in a galaxy combined. It's not a violent collision, but a graceful blending, two infinities becoming one. In that merging lies a strange beauty. Even darkness is capable of union, and even the most isolated parts of creation can meet and become whole. Fact 52. Ripples in the cosmic fabric. When two black holes collide, they don't just move through space, they stir it. The immense change in gravity sends out waves that ripple through space-time itself, like circles spreading across a still pond. These gravitational waves carry energy, stretching and squeezing the very fabric of the cosmos as they travel. They move at the speed of light, yet they are faint. So faint that when they pass through Earth, they distort everything by less than the width of an atom. And yet, those tiny ripples tell enormous stories of distant collisions, of black holes meeting in the dark, of galaxies trembling softly in their wake. The universe is not silent after all. It hums quietly, eternally, with the echoes of gravity's dance, a cosmic heartbeat pulsing through the deep. Fact 53. The whisper of gravitational waves. Gravitational waves are the universe's most delicate form of communication. Invisible, silent, yet infinitely revealing. They travel across billions of light years without losing their rhythm, carrying with them the memory of ancient events, stars colliding, black holes merging, even the faint echoes of the Big Bang itself. Detectors on Earth, like LIGO and Virgo, can sense these whispers, translating the vibrations of spacetime into sound. What they record is not a roar, but a gentle chirp, the final heartbeat of two black holes becoming one. These waves remind us that even in the darkness, the universe keeps speaking, softly and steadily, in a language older than light. Every ripple that reaches us is a story of creation and completion, a note in the cosmic symphony of silence and motion. Fact 54. LIGO's first cosmic note. In 2015, humanity heard the universe for the first time. Two black holes, each more massive than the Sun, collided over 1 billion light-years away, sending ripples through space-time that reached Earth as a faint vibration. The LIGO detectors, built to measure distances smaller than an atom, captured the signal. A brief rising chirp that lasted less than a second. But that sound confirmed a century-old prediction from Einstein's theory and opened a new era of astronomy. For the first time, we could not only see the cosmos, but hear it, sensing the movement of invisible giants. The discovery was a triumph of patience, technology, and human curiosity. That quiet tone, traveling for 1 billion years to touch our world, was the sound of the universe breathing, proof that even silence carries song. Fact 55. The music of collapsing suns. When massive stars collapse or black holes merge, they send out waves through spacetime, not of sound, but of motion itself. These gravitational waves are the true music of the cosmos, vibrations that no ear can hear but every atom can feel. Scientists have translated some of these signals into audible tones, low, brief hums that rise and fall like a sigh. Each note represents a cosmic event billions of years old, reaching us only now. It's astonishing to think that the universe, once thought silent, sings constantly, not in air or echo, but in the very geometry of existence. Every black hole, every collision, adds a new verse to this eternal song, proof that creation and stillness can coexist in the same soft vibration. Fact 56. Chirps in the silence of space. When two black holes spiral together, their dance creates a pattern, a rising pitch of gravitational waves that scientists call a chirp. It begins deep and slow, then quickens as the black holes draw closer, until the final moment when they merge into one. That last fading tone carries across the universe, a brief signal that tells of unimaginable power released in perfect symmetry. LIGO recorded these chirps and translated them into sound, tiny bursts lasting just a heartbeat, yet holding the story of entire galaxies. In those short whispers lies everything: gravity, motion, and time collapsing into unity. The chirps of black holes remind us that even in silence, the universe has rhythm, a slow cosmic pulse that never stops beating, guiding stars and galaxies through their eternal dance. Fact 57. When space itself rings. When black holes collide, space doesn't just tremble, it rings. After the violent merger, the new, larger black hole vibrates briefly as it settles into balance. These oscillations, called the Ringdown, release the final echoes of energy before calm returns. To astronomers, these waves are precious clues, revealing the mass, spin, and shape of the newborn black hole. The process is like striking a cosmic bell, one made not of metal, but of space-time itself. Each ring fades softly into silence, yet its pattern endures in the universe's memory. It's astonishing to imagine space behaving like a resonant instrument, its surface quivering, then stilling once more. In that fading tone lies serenity, the moment when motion becomes peace, and gravity hums its final gentle note into the quiet. Fact 58. Black holes as cosmic instruments. Each black hole is like a vast, invisible instrument, not of strings or wind, but of space-time itself. When they collide or quiver, they send vibrations through the universe, just as a struck bell sends ripples through air. The pitch of these waves depends on the black hole's mass and spin. Smaller ones create higher tones, while giant ones hum in deeper frequencies, too low for human ears. Scientists can translate these signals into sound, allowing us to listen to the movement of gravity. Every tone is pure, every vibration mathematical perfection, a song written not in melody, but in motion. To imagine space ringing is to realize how alive the cosmos truly is, not silent, but softly singing, its harmonies carried across eternity through the quiet pulse of merging shadows. Fact 59. The soundtrack of merging universes. When black holes collide, they briefly reshape the universe. For that moment, their merger releases more energy than every star shining in every galaxy combined. Yet to us, it arrives not as light, but as a delicate vibration, a rising hum that lasts less than a heartbeat. These gravitational waves ripple outward, crossing galaxies, drifting through the void until they brush against our planet, ever so faintly. The detectors that hear them, like LIGO and Virgo, record these fleeting songs, each one unique, each one a cosmic symphony condensed into a whisper. These sounds are not noise, they are history, the echoes of creation continuing to unfold. To listen is to touch the heartbeat of the universe itself, steady and eternal, playing softly in the silence between the stars. Fact 60. The universe's quiet symphony. The universe is not silent, it hums. Its music is not heard through ears, but through the language of physics, a grand symphony of motion, vibration, and time. Every black hole, every collision, every faint ripple in space-time contributes to this vast harmony. Some waves rise and fall quickly, others drift slowly across eons, too long for us to perceive. Together, they weave the gravitational background, a constant, gentle chorus echoing through all of existence. Astronomers are only beginning to detect it, the low, steady song of the cosmos breathing. It's a lullaby of balance and transformation, carrying the memory of every star that ever was. In that quiet symphony, we are participants too, made of the same fabric, resonating in time with galaxies, listening softly to the universe's eternal music. Fact 61. The Firewall Paradox. In theory, crossing a black hole's event horizon should feel calm. General relativity predicts nothing unusual, no barrier, no fire. Yet quantum physics offers a different story. Some scientists propose that the horizon might blaze with searing energy, a firewall that destroys everything that touches it. This idea challenges our understanding of space-time, suggesting that information and energy collide in violent contradiction. But most physicists hope the universe is kinder, that nature preserves harmony even at its most extreme. The Firewall paradox remains unsolved, a puzzle between two great truths: Einstein's smooth geometry and quantum theory's restless uncertainty. Somewhere between them lies the quiet answer, hidden beyond the reach of observation. Perhaps, like many cosmic mysteries, the truth is softer than we imagine, a balance, not a burn, waiting in the dark. Fact 62. The puzzle of information. One of the most haunting questions in physics asks, what happens to information that falls into a black hole? According to quantum mechanics, information, the fundamental record of how particles are arranged, can never truly be destroyed. Yet a black hole seems to erase it completely. This is the information paradox, a mystery that blurs the boundary between existence and oblivion. Some scientists believe the information remains encoded on the black hole's surface, like ripples on a vast hologram. Others suggest it is transformed, preserved in ways we cannot yet perceive. Whatever the truth, the paradox forces us to confront an idea both profound and peaceful: that nothing in the universe ever fully disappears. Even in darkness, memory persists. The black hole may not destroy what it consumes. It may simply hold its secrets in silence. Fact 63. Does data die in darkness? When light, matter, and energy vanish beyond a black hole's horizon, it seems as though they are lost forever. But physics whispers another possibility. Perhaps nothing is truly lost, merely hidden. Some theories suggest that black holes store everything they absorb, not inside, but upon their surface, encoded in patterns too subtle for us to see. Others imagine that this information may one day be released through Hawking radiation, scattering the universe's memories slowly back into space. If so, then every black hole is not a grave, but a library, a silent archive of all it has touched. The data may be unreadable to us, yet it endures in the structure of space-time itself. Even in perfect darkness, the universe keeps its records, ensuring that every story, every atom, is remembered, softly, forever. Fact 64. Hawking's Paradox and Promise. In 1974, physicist Stephen Hawking made a discovery that forever changed our view of black holes. He proposed that, contrary to all belief, black holes are not completely black. Through the delicate dance of quantum mechanics, they can emit faint particles of energy, now called Hawking radiation. This idea was revolutionary because it meant black holes could slowly lose mass and eventually fade away. But it also deepened the mystery. If black holes evaporate, where does the information they contain go? Hawking's insight bridged two worlds, relativity and quantum theory, and sparked decades of wonder and debate. His work showed that even the darkest places in the universe are not silent forever. They shimmer with possibility. In their slow evaporation, black holes promise a kind of renewal, the quiet return of what once seemed lost. Fact 65. Quantum flickers at the edge. At the boundary of a black hole, space is alive with invisible activity. Tiny pairs of particles constantly appear and vanish, born from the energy of the vacuum itself. Normally, they annihilate each other instantly, but near the event horizon, one particle can fall inward, while the other escapes. To a distant observer, that escaping particle looks like radiation, softly glowing from the black hole's edge. This is quantum fluctuation, a delicate balancing act between existence and non-existence. It reminds us that even emptiness is not truly empty. It hums with possibility. Every black hole, once thought to be silent, hums gently too, surrounded by this faint halo of quantum life. It's as though the universe refuses to allow perfect stillness, insisting that even in the deepest quiet, something must always whisper back. Fact 66. Hawking radiation's gentle glow. Hawking radiation is unimaginably faint, far too weak for us to detect with today's instruments. Yet its existence reshapes our understanding of reality. Over billions of years, this soft glow slowly drains a black hole's energy, causing it to shrink and eventually vanish. For the largest black holes, this takes longer than the current age of the universe. Still, the principle stands. Even the most enduring giants must one day fade. The radiation itself is serene, not a blaze but a sigh, a steady release of borrowed heat back into the cosmos. It is the universe's way of balancing its books, ensuring that nothing lasts forever, not even the dark. In that gentle decay lies a quiet beauty, the reminder that endings too can be peaceful, that even darkness ends not in violence, but in light. Fact 67. Evaporation over eons. Black holes are often called eternal, but even they have lifespans. Through the slow release of Hawking radiation, they lose energy over unimaginable stretches of time. A small black hole might vanish in seconds, while a supermassive one, like the heart of our Milky Way, could take more than 10 to the 67th power years to fade away. The process is gentle, not an explosion, but a gradual unwinding. The black hole shrinks, warms, and releases its last whispers of energy into the cold void. Over eons, its gravity weakens, its presence softens, until it disappears completely, leaving only faint radiation as a signature. This cosmic evaporation is the universe's quiet recycling, the slow return of matter and energy to the sea of space. Even the darkest things, it seems, are destined to dissolve peacefully into light. Fact 68. When black holes fade like embers. In their final stages, black holes may glow like dying coals, faint and warm, radiating their last traces of energy before vanishing. This light is the echo of countless years, the end of a journey that began with the collapse of a star. As the black hole shrinks, its temperature rises, and the radiation intensifies until, at last, it releases one final burst of brilliance, a last flicker of existence. Then it is gone, leaving only waves of energy drifting through the darkness. It's a gentle reminder that even the most powerful forces yield to time. The black hole's end is not destruction, but transformation. Energy set free, returning to the fabric from which it came. In that final warmth, the universe remembers, and the cycle of creation continues in silence. Fact 69. Virtual particles and borrowed light. The mystery of Hawking radiation arises from the strange behavior of virtual particles, tiny pairs that constantly appear and disappear in empty space. Normally, they cancel each other out, borrowing energy from the vacuum for only a moment. But near a black hole's edge, one particle can fall in while the other escapes, carrying away a small amount of energy. The escaped particle becomes real, a spark of borrowed light, paid for by the black hole's own mass. Over time, countless such moments drain its energy, one particle at a time. It's an elegant trade, written in the language of quantum physics, existence borrowing from nothingness, and nothingness giving back in kind. These flickers, invisible and silent, show that even in the depths of gravity, the rules of creation still play softly, endlessly, fair. Fact 70. the universe's slow return. When a black hole finally fades through Hawking radiation, it gives back to the universe everything it once consumed, not as matter, but as pure energy. Over countless eons, these gentle emissions will help warm the coldest reaches of the cosmos, a final offering before silence. In the far future, when the last stars have burned out and only black holes remain, this quiet release will be the universe's final breath. Every photon that escapes will carry with it the memory of countless suns and galaxies that once were. It's a slow return, patient, complete, and balanced, reminding us that nothing is ever truly lost. The cosmos always finds equilibrium, even in darkness. In that endless stillness, the energy of creation drifts back into the vastness, like the tide receding from the shore of time. Fact 71. Galaxies shaped by darkness. Black holes are not just endings, they are architects. At the heart of nearly every galaxy lies a supermassive black hole, and its gravity quietly organizes the chaos around it. The energy it releases while feeding can push gas outward, shaping how stars form and where they gather. When it sleeps, galaxies grow calm. When it feeds, galaxies flare with new creation. Astronomers now know that the size of a galaxy is deeply connected to the mass of its central black hole, a perfect balance between darkness and light. Without these hidden anchors, galaxies might scatter, their stars wandering unbound. Black holes hold them together, their invisible pull writing the quiet choreography of cosmic structure. In their stillness, they sculpt beauty, proof that even shadows can build worlds, and that silence too has power. Fact 72. Jets that seed the stars. Some black holes, especially those in active galaxies, release vast jets of energy that stretch across intergalactic space. These jets are born from twisted magnetic fields near the black hole's poles, hurling particles outward at nearly the speed of light. Though fierce, they bring creation, not destruction. As the jets pierce the surrounding gas, they stir it, compress it, and spark the birth of new stars. The same force that consumes matter can ignite new suns. The universe's delicate balance between ending and beginning. From millions of light years away, these jets look like luminous threads, weaving through the dark fabric of space. They are reminders that even from the deepest gravity wells, energy escapes to give life elsewhere. The black hole, in its own quiet way, becomes both devourer and gardener, sowing starlight through the dark. Fact 73. Energy. Feeding the cosmos. Though black holes consume everything that crosses their horizon, the process of feeding releases enormous energy into space. As matter spirals inward, friction and magnetism heat it to staggering temperatures, unleashing light, radiation, and motion that reach across galaxies. These outbursts can trigger star formation in distant clouds or sweep gas into new shapes, guiding the evolution of entire galaxies. It's a paradox of beauty. The more a black hole feeds, the more life it inspires beyond its reach. What seems like destruction is actually transformation. Matter turning into light, energy returning to the cosmos in a radiant cycle. Black holes are not mere voids. They are cosmic engines, converting gravity into illumination. Through their quiet hunger, the universe finds renewal, proving that even in darkness, creation continues to bloom. Fact 74. Black holes as architects of order. For all their mystery, black holes bring structure to the cosmos. Their immense gravity gathers wandering stars, steadies galactic centers, and defines the boundaries between chaos and calm. Without them, galaxies might scatter and lose their graceful spirals. Black holes act as anchors, invisible architects ensuring that stars, dust, and time itself orbit in harmony. When they feed, they regulate the energy around them. When they rest, they hold everything steady. This delicate push and pull creates the balance necessary for galaxies to endure for billions of years. It's humbling to think that what seems like destruction actually maintains order, that these silent giants keep the universe from unraveling. In their stillness, black holes design the grandest patterns of all, sketching galaxies from gravity and silence, building beauty from the unseen. Fact 75. Silent balance in cosmic chaos. The universe is full of motion, stars exploding, galaxies colliding, space expanding. Yet amid this endless movement, black holes bring equilibrium. Their gravity gathers what drifts apart. Their energy releases what gathers too close. This interplay keeps galaxies alive, balancing creation and collapse. Even chaos needs symmetry, and black holes provide it. They are the still points around which the cosmos turns, vast centers of quiet amid infinite noise. From far away they appear destructive, but in truth they are mediators, restoring calm wherever the universe grows restless. Without them, galaxies would lose their rhythm, and light would have no horizon to frame its glow. In the dance of existence, black holes are the silent steps between beats, invisible, patient, eternal, keeping harmony in a universe that never stops moving. Fact 76. Why galaxies dance around shadows. Every galaxy spins around something unseen, a dark, steady center where gravity rules without light. That center is a supermassive black hole, guiding billions of stars like a silent conductor. Though it makes up only a tiny fraction of the galaxy's total mass, its presence determines how everything moves. Stars orbit faster near the heart, slower at the edges, tracing graceful spirals through the dark. This dance is ancient and constant, a rhythm written in gravity. The galaxy's beauty, its arms, its balance, its form, all arise from this invisible anchor. What seems empty is, in truth, the source of order. Around every shadow, light finds its path, and through every quiet center, the universe keeps time. The galaxies do not just exist beside black holes. They move to their music. Fact 77. The bond between mass and light. Black holes reveal an intimate connection between mass and light, between gravity's strength and the glow it controls. The greater a black hole's mass, the more it bends the paths of nearby photons, shaping how light moves and where it lingers. In this relationship lies a quiet poetry. Mass defines the curve, and light paints the edges. Without gravity, light would travel forever in straight lines, and the universe would lack depth, contrast, and form. But because mass bends it, we see halos, arcs, and spirals, the artwork of gravity's touch. Around black holes, this relationship becomes most profound. Light circles darkness, illuminating its outline but never escaping. In their bond, the cosmos finds balance, brightness and shadow intertwined, neither complete without the other, eternally shaping one another in the silence of space. Fact 78. The sculptors of spiral arms. The majestic spirals of galaxies are not mere accidents of motion. They are shaped by gravity's quiet artistry. At the center of many, a supermassive black hole anchors the flow of stars and gas, its pull ensuring that the galaxy's structure remains steady. As stars orbit, their paths trace waves through the galactic disk, ripples that form luminous arms spiraling outward. These arms are regions of birth and renewal, where gas clouds compress and new stars ignite. Without the stabilizing presence of black holes, these patterns would drift apart over time, dissolving into chaos. Instead, the universe remains organized, graceful, and rhythmic. The black hole does not force this order. It simply is, a stillness that allows motion to exist around it. In the quiet heart of every spiral, the cosmos sculpts beauty from balance. Fact 79. The quiet regulation of creation. Black holes are often described as destroyers, but in truth, they act more like regulators of creation. When they feed, the energy they release can push gas and dust away, preventing too many new stars from forming at once. When they rest, those same materials drift back, ready to birth fresh generations of suns. This gentle balance keeps galaxies from collapsing under their own abundance or fading too quickly into emptiness. It's a cosmic rhythm: inhale and exhale, expansion and rest. Through this cycle, black holes maintain the delicate harmony that allows galaxies to evolve for billions of years. Their influence is unseen but essential, like the steady pulse that keeps the universe's heart beating softly, endlessly, with order beneath the illusion of chaos. Fact 80. The breath of the universe's heart. At the center of every galaxy, the supermassive black hole acts like a great slow heartbeat, inhaling matter and exhaling energy in cosmic rhythm. When it feeds, radiation floods outward. When it pauses, the galaxy quiets. These alternating cycles can last millions of years, shaping how galaxies grow and glow. The black hole's breath sets the tempo for the life around it, stirring clouds, guiding stars, and balancing creation with stillness. Astronomers studying distant galaxies see evidence of this pulse in waves of light and motion, spreading gently across space. It's as if the universe itself breathes through these vast, invisible hearts, slow, patient, eternal. And though we cannot hear the sound, we can feel it in the movement of everything. A rhythm so grand and steady that even time seems to sway with it. Fact 81. Black holes in fiction and dream. Long before science could prove their existence, black holes lived in our imagination. They were doorways, monsters, mirrors, and mysteries, symbols of the unknown. In stories, they became portals to other worlds or metaphors for fear, curiosity, and transcendence. Artists and writers saw in them something deeply human, our longing to understand the unseen. Today, even as we study them through telescopes and equations, they remain poetic, reminders of how wonder and knowledge are entwined. The black hole is both scientific truth and dream symbol, both reality and reflection. It shows us that curiosity itself is infinite, that imagination reaches just as far as gravity pulls. In the darkness we once feared, we now find beauty, a soft, endless reminder that mystery, not certainty, is what keeps us reaching for the stars. Fact 82. Gateways to elsewhere. For centuries, black holes have inspired a question both scientific and spiritual. What lies beyond? If nothing can escape their gravity, could something perhaps travel through? Some theories suggest that deep within their cores, black holes might connect to other regions of spacetime, perhaps even to other universes. These hypothetical tunnels are called wormholes, passages that curve through dimensions unseen. Though unproven, the idea stirs the imagination, a door made not of matter, but of geometry itself. If such gateways exist, they may be short-lived, unstable, or forever closed to travelers. Yet the concept reminds us that the universe may be far larger and stranger than we can yet perceive. In black holes, we find not just endings, but possibilities, dark mirrors hinting that every collapse might also be an opening into somewhere new. Fact 83. Einstein-Rosen bridges and wormholes. In 1935, Albert Einstein and physicist Nathan Rosen proposed a remarkable idea that black holes might form tunnels through spacetime, now known as Einstein-Rosen bridges. These bridges could, in theory, connect two distant regions of the universe, or even two separate universes entirely. To an observer, they might appear as paired black holes, one devouring matter and the other releasing it. Though later studies suggest such wormholes would be unstable, collapsing faster than light could pass through them, the concept endures as one of physics' most poetic speculations. It merges mathematics with mystery, the notion that the cosmos folds upon itself, allowing shortcuts through infinity. Whether real or symbolic, wormholes remind us that the universe may contain paths hidden within its own curves, and that imagination often arrives at truth long before proof. Fact 84. Falling through to another universe. If wormholes could exist, they might provide passage between realities, bridges from one universe to another. Some theories describe them as tunnels lined with warped space-time, where time and distance blur and directions lose meaning. Traveling through one might feel like falling forever, only to emerge somewhere else entirely, under a different sky. Of course, this remains pure speculation. No evidence yet shows that such paths are stable or traversable, but the idea speaks to something deeper within us. The yearning to explore beyond limits, to turn endings into beginnings. A black hole's pull, then, becomes symbolic, the invitation to surrender, to cross from known to unknown. Whether or not we ever pass through such a doorway, the thought itself reminds us that the universe's greatest gift may be its endless capacity to surprise. Fact 85. The time machines that might be. Black holes twist not only space, but time. In theory, a spinning black hole, known as a Kerr black hole, might allow paths that loop backward through time. Inside its swirling geometry, there could exist regions where cause and effect trade places, where yesterday and tomorrow overlap like shadows on water. Though such travel remains impossible for us, these solutions to Einstein's equations reveal how flexible reality can be. Time, once thought absolute, becomes fluid near the horizon of infinity. While most physicists believe these loops would collapse before anyone could pass through, their existence in theory reminds us that time is not a straight line, but a fabric that can fold. In the quiet near a black hole, perhaps time doesn't end or begin. It simply circles endlessly in thought and dream. Fact 86. Inside the mathematical mirage. When we speak of black holes, we often speak in paradoxes. Their descriptions arise not from direct observation, but from mathematics, elegant equations that predict what no eye can see. Inside these formulas are infinities, regions of impossible density and timelessness. Yet mathematics does not fear infinity. It welcomes it as part of its language. To physicists, a black hole is both real and symbolic, a perfect solution to Einstein's field equations, existing wherever mass collapses beyond return. But these equations also suggest beauty, symmetry, balance, and a strange calm at the edge of the knowable. The black hole becomes more than an object. It becomes an idea, a mirror of the universe's logic. Within its numbers, the cosmos speaks softly, revealing that behind every mystery lies a pattern, infinite, precise, and serene. Fact 87. The holographic horizon. Some physicists believe that everything inside a black hole, every particle, every piece of information, is somehow encoded on its event horizon, like a cosmic hologram. This is the holographic principle, a bold idea suggesting that our three-dimensional reality might be a projection from a two-dimensional surface. If true, then black holes don't destroy information at all. They store it on their boundaries, woven into the very texture of space. This principle has led to an even deeper question. Could the entire universe be holographic? Its depth an illusion born from information written on a distant surface? It's a thought that blurs science and philosophy, turning perception into mystery. The black hole's horizon, once a symbol of finality, becomes a canvas, holding not the end of things, but their reflection, perfectly preserved in lightless silence. Fact 88. Are we living in reflection? If the holographic principle is true, then everything we see, stars, galaxies, even ourselves, could be the projection of information written on a distant cosmic surface. In this view, depth is illusion, and reality is a grand three-dimensional echo. Some physicists compare it to a film. The universe plays out in motion and light, while the true script lies on a flat, invisible screen at its boundary. Though unproven, the idea reshapes how we think of existence itself. It suggests that matter, time, and energy are secondary, that information is the true essence of being. Perhaps, then, black holes are not destroyers, but archivists, preserving the universe's data in perfect symmetry. In their reflection, we glimpse ourselves, patterns of light and memory, written softly into the geometry of the cosmos. Fact 89. The quantum surface of reality. At the smallest scales, the smooth fabric of spacetime begins to shimmer. Physicists call this the quantum foam, a restless ocean of tiny fluctuations where space and time appear to flicker in and out of existence. Near a black hole, this quantum texture becomes even more pronounced. The event horizon might not be smooth at all, but rippled with minute information patterns, each carrying clues to what lies within. Every flicker encodes energy, gravity, and possibility, like the pixels of a cosmic screen. In this quantum view, reality itself is granular, not continuous, but woven from countless bits of information. Black holes, then, are both boundaries and blueprints, showing us that existence may be digital at its foundation. What seems infinite and soft is, up close, a quiet mosaic of certainty, the universe written in particles of light. Fact 90. Information as the true substance. In the deepest interpretations of physics, information may be more fundamental than matter or energy. Every particle, every photon, every field can be described by the data that defines its state. Even black holes, the universe's most mysterious objects, seem to obey laws of information, storing, processing, and radiating it with absolute precision. The universe behaves almost like a vast computation, unfolding patterns across spacetime, governed not by chaos, but by logic. In this vision, we are part of that code, consciousness as information arranged in living form. Black holes remind us that nothing truly disappears, it simply changes its description. The cosmos may not be a machine, but a story, endlessly written and never erased. If information is the true fabric of reality, then we are, each of us, threads of the same quiet equation. Fact 91. The black hole era of the universe. Far beyond our time, when all stars have faded and galaxies have scattered, a new cosmic age will begin, the black hole era. In this distant future, trillions of years from now, only black holes will remain, silent and patient, scattered through the cold expanse. They will be the final engines of gravity, the last active structures in a universe grown dim. Around them, faint radiation will drift, and matter will exist only as whispers of particles. Time will stretch so long that even seconds will lose meaning. Yet these black holes will continue to shape the void, slowly releasing their stored energy through Hawking radiation, giving back to space what they once took. In this twilight epoch, the universe will still hum softly, gravity's final breath, echoing through the endless dark. Fact 92. When stars go out forever. One day, far in the future, every star will exhaust its fuel. The bright constellations that now fill our sky will fade, one by one, until the heavens are dark. Red dwarfs will burn the longest, glowing dimly for trillions of years, before finally cooling to black. The night will no longer shimmer with starlight, only the faint glimmer of distant galaxies, and then even those will vanish. In this deep silence, black holes will rule as the last luminous entities, their accretion disks glowing faintly from what little matter remains. The universe will enter a long sleep, its light turned inward, its warmth fading into memory. Yet even in this stillness there is beauty, the calm that follows creation, when the cosmos, having burned bright for eternity, finally closes its eyes and rests. Fact 93. The universe's long fade. After the last stars die, the universe will not end abruptly. It will simply fade. Light will stretch, wavelengths lengthening as expansion carries it beyond perception. Galaxies will drift apart until they can no longer see one another, and space will grow colder with every passing aeon. Black holes will persist as quiet anchors, slowly evaporating in the darkness. Eventually, even they will vanish, leaving only a thin mist of radiation, the faint afterglow of everything that once was. This is the heat death of the universe, not a cataclysm, but a perfect stillness. Time will continue, yet nothing will change. It is the final exhale of creation, the softest possible ending. And though all motion ceases, the memory of stars, light, and life will remain, carried forever in the calm, eternal hum of space-time. Fact 94. The last black holes still spinning. Long after galaxies dissolve and starlight fades, a few black holes will remain, still turning, still holding the memory of their origins. These ancient giants will spin silently for unimaginable stretches of time, their immense gravity curving what little remains of space-time. Their rotation, preserved for trillions of years, will be one of the universe's last forms of motion. Around them, nothing will move, only the faint hum of quantum energy, the slow ticking of eternity. As they emit their final traces of Hawking radiation, their mass will dwindle, their spin will slow, and their presence will dim like embers cooling in infinite night. These last black holes will mark the closing chapter of creation, the final rhythm before stillness, reminders that even in darkness, the universe continues to turn gently until the very end. Fact 95. Entropy's quiet victory. In physics, entropy is the measure of disorder, the natural tendency of energy to spread and even out. Over time, entropy always increases, guiding the universe toward balance. Black holes, though they seem like perfect order, actually contain immense entropy, encoded on their event horizons. They are nature's record keepers, storing the disorder of everything they consume. When the last black holes fade away, entropy will reach its peak, total equilibrium, when no energy can flow and no change can occur. This final stillness is not tragedy, but completion. It is the universe's long sigh of fulfillment, the moment when everything finds perfect calm. In that balance, creation's story closes softly, not with destruction, but with peace. The endless quiet of a cosmos that has given all its light back to itself. Fact 96. Hawking's final glow. As the last black holes shrink to nothing, they will release their remaining energy in one brief radiant burst, a final glow of Hawking radiation. This will be the universe's last light, faint but pure, spreading through an ocean of silence. No stars will shine, no galaxies will glimmer, only these fleeting sparks, marking the end of gravity's long reign. Each dying black hole will release everything it once held, returning its borrowed energy to the void. And then, as the glow fades, darkness will reign completely, but it will be a peaceful dark, empty of fear, filled only with stillness. In that moment, the universe will have completed its great cycle, from light to shadow, from chaos to calm. The final whisper of radiation will be the universe's soft good night, a farewell written in fading warmth. Fact 97. The slow dissolve of darkness. After the last light fades, even darkness will begin to dissolve. The final black holes will vanish, leaving only a thin mist of low-energy radiation, the faint echo of everything that ever was. Space will stretch endlessly, growing colder, emptier, quieter. Time will still pass, though it will have little left to measure. The universe will not end in fire, but in a sigh, an infinite peaceful fading. This quiet dissolution is not loss, but return. Every atom, every photon, every shadow blending back into equilibrium. In this endless stillness, the cosmos will finally rest, having completed its long journey from brightness to calm. What remains is not void, but balance, a vast serenity where energy, matter, and time are one. The universe will have found its natural state, perfect, silent harmony. Fact 98. What remains when all is gone? When the last black hole evaporates, and even the faintest photons drift into nothingness, something will remain. Not matter, not energy, but the laws that shape them. The structure of space-time, the equations of physics, and the quiet symmetry of existence will still persist, woven into the emptiness. These are the true remnants of creation: order, logic, and possibility. They are the silent framework that once gave birth to stars, life, and thought. Even when all forms of energy disperse, the essence of being, the capacity for existence, will linger. It may never manifest again, yet its presence will be eternal, like a melody whose final note still vibrates in silence. What remains when all is gone is not nothing, but everything distilled. The pure idea of a universe resting quietly beyond time. Fact 99. The calm after creation. After the long ages of motion and light, the universe will rest. Every burst of creation, every flicker of destruction will have balanced itself into stillness. The stars will have sung their last songs, the galaxies will have scattered, and even gravity will have released its final grip. What follows is peace, not empty, but fulfilled. In this calm, the universe will be whole again, without separation or struggle. No warmth, no cold, no before or after. Only the quiet presence of what once was. Perhaps this is not an ending, but a kind of meditation. The cosmos breathing out after an eternity of breath. In that infinite exhale lies something almost sacred, the realization that all beginnings must lead here, to rest, to balance, to the soft, eternal peace beyond creation. Fact 100. Stillness eternal. In the end, the universe does not collapse or burn. It simply settles into stillness, calm, balanced, complete. The echoes of creation fade into silence, and the darkness that remains is soft, peaceful, and infinite. Black holes, once fierce and mysterious, have given back their energy, their light, their memory. What remains is neither nothing nor something, but serenity itself, the quiet fulfillment of everything that ever was. Time stretches without meaning. Space exists without edge. In this vast, unbroken calm, the cosmos finds its true nature. Rest. Every star, every atom, every thought returns to the same silence from which it began. The universe no longer expands or contracts. It simply is, weightless, timeless, eternal. And in that stillness, there is beauty, the quiet truth that even endings can feel like peace. And as our journey comes to a gentle close, I hope you found a bit of calm among the stars tonight. If you enjoyed drifting through these sleepy facts, don't forget to like the video, subscribe, and share what topic you'd love to fall asleep to next. When you're ready to keep dreaming, tap the end screen to watch the next Sleepy Astronaut video and continue your quiet voyage through the universe. Until then, may your thoughts be weightless, your dreams luminous, and your heart as still as the space between the stars. Sweet dreams.